Now let us talk about weighted graph. A weighted graph is a graph in which each branch is given a numerical weight. A weighted graph is therefore a special type of labeled graph in which the labels are numbers which are usually taken to be positive. Ang weighted graph daw po ay isang uri ng graph na may label ang bawat branch o edge nito. Ang mga label na ito ay kadalasan mga positibong numero. A weighted graph is a graph where each edge has a numerical value called weight. Sa ibang salita po, ang weighted graph ay isang graph kung saan ang bawat edge o bawat linyang kumokonekta sa dalawang punto o vertex ay mayroong bilang na tinatawag na weight. Given below is an example of a weighted graph. Makikita po natin sa ibaba ang isang halimbawa ng weighted graph. The graph consists of 5 nodes and 7 edges. Let's zoom in the graph para mas makita po natin. Yung 5 nodes po na sinasabi rito ay itong vertex 0, 1, 2, 3, and 4. Note that when we say nodes, points and vertex or vertices, plural ng vertex, para-pareho lang po yung tinutukoy natin. They are similar terms used to describe these things in a graph. Yung 7 edges naman po are these lines. 1, 2, 3, 4, 5, 6, and 7. Notice that each edge has a weight. For example, the edge that connects nodes 0 and 3 has the weight 7. Yung edge naman na nag-uugnay sa nodes 1 and 2 ay may bilang na 1. Weighted graphs are often used to model real objects and processes. For example, the graph above can be considered as a map, where the nodes are cities and the edges are roads. The weight of each edge is the distance between two cities. Sabi po dito, ang weighted graphs ay kadalasang ginagamit to demonstrate real-life situations. Gaya po ng graph dito, pwede po natin siyang gawing mapa para makita ang layo ng bawat lugar. We just have to assume that the nodes or vertices represent cities, yung edges naman ay yung roads, habang yung weight or numerical value naman ng bawat edge ay yung distansya sa pagitan ng dalawang lugar o syudad. The graph above is an undirected graph, but graphs can also be directed. May dalawang uri po ng graph, undirected and directed graph. Yung graph po kanina ay isang halimbawa ng undirected graph, meaning, yung edges po niya are not arrows and all edges are bidirectional. Kapag sinabing bidirectional po, yung relationship between two nodes ay two-way relationship, meaning A is related to B and B is related to A. For example, crush ni A si B at crush din ni B si A. Meanwhile, kapag directed graph po, edges are presented in arrows and all edges represent a one-way relationship. They are a relationship from one node to another node but not backwards. Meaning, A is related to B but B is not related to A. For example, crush ni A si B pero hindi crush ni B si A. Given below is an example of a directed weighted graph. Let's zoom in the graph para mas makita natin na directed weighted graph nga siya. So dito, makikita po natin na each edge has weight. Tsaka yung edges po niya are presented in arrows showing a certain direction. Gaya po nito. One way lang din po yung relationship. For example, itong node 0 is papunta roon sa node 1. Pero si node 1, hindi siya papunta kay node 0. Instead, itong si node 1 ay directed to node 2. Weighted directed graphs can also be used to model some real processes. Gaya po kanina doon sa undirected weighted graph, pwede rin natin i-apply sa real situations yung weighted directed graphs. For instance, the node 0 in the graph can be considered as a storage place, from where we need to transfer some resources to the destination point, say to the node 2. Halimbawa po, itong si node 0 ay isang imbakan. Let's say imbakan ng bigas. Mula po rito kay node 0 ay kailangan nating maglipat ng bigas patungo doon kay node 2. The remaining nodes can be considered as intermediate places. Yung mga natirang nodes or vertices like 4, 3, and 1, ito yung mga lugar sa pagitan ni node 0 at node 2 na pwede nating daanan para makarating tayo sa destination point which is node 2. Each edge shows a direction in which the resources can be transferred. Bawat edge po sa graph na ito ay nagtuturo kung saan natin pwede ilipat o idaan yung bigas para makarating kay node 2. The weight of an edge shows the maximum amount of resources that can be sent through the edge. Yung weight po ng edge ay indicator kung ilan ang pinakamataas na bilang ng sako ng bigas na pwedeng idaan sa isang edge. Halimbawa po, in the edge that connects vertices 0 and 1, 3 sacks of rice can be sent through that edge. Note that for the graphs above, all the weights are positive, but negative and zero weights are also allowed. Mapapansin po natin na yung weights ng edges na nakalagay sa example graphs ay lahat positive, pero sa ibang graphs po, may mga edge na negative or zero yung numerical value at accepted po iyon. Now let us proceed to the representation of weighted graphs. An unweighted graph can be represented using an adjacency matrix or an adjacency list. A weighted graph can also be represented using both of these structures. Sabi po rito, pwede po natin gamitin ang adjacency list o ang adjacency matrix para makagawa po ng representation ng isang weighted graph. Alinman sa dalawa ay applicable po when doing a representation of a weighted graph. Unahin po natin yung adjacency matrix. Ano nga ba ito? An adjacency matrix is a two-dimensional array which represents a data structure. Sa ibang salita po, ito ay isang paraan ng pag-aayos ng datos kung saan ang mga numero ay nakaayos sa loob ng rows at columns. In other words, naka-table po. Para mas maintindihan pa po natin yung concept ng adjacency matrix, gagawan po natin ng adjacency matrix yung example po ng weighted directed graph kanina. So, ito po yung graph na gagawa natin ng adjacency matrix. Ito naman po yung format ng adjacency matrix na gagawa natin to represent this graph. Itong numbers po na nasa gilid ay yung vertices na makikita sa graph. So here we have vertex 0, 1, 2, 3, and 4. Itong numbers naman po na nasa itaas, same lang din po. Vertices pa rin po ito. Makikita po natin na sa matrix na ito ay mayroong 5 rows, 1, 2, 3, 4, and 5. Mayroon din pong 5 columns, 1, 2, 3, 4, and 5. Kasi nga po, meron din pong 5 vertices na given doon sa graph. Sa loob po nitong rows and columns, dito po natin ilalagay yung weight ng edges between the vertices. So as you can see po, may mga zeros po dito. Tandaan po natin na kapag 0 yung value, it means wala pong edge na makita between two vertices. Zeros po muna yung nilagay ko sa lahat ng columns and rows para mamaya po, papalitan na lang po natin ng tamang weight o value yung vertices na may edges. Tandaan po natin ulit na kapag yung value na nakalagay sa matrix ay greater than 0, it means po na may edge sa pagitan ng dalawang vertices. So, let's start. Makikita po natin dito sa graph that there's an edge from vertex 0 to vertex 1. At yung weight po ng edge ay 3. So, ilalagay po natin dito sa matrix that from vertex 0 to vertex 1, yung weight po ng edge ay 3. Okay. So, dito naman po, from vertex 0 to vertex 3, yung weight po ng edge ay 7. So, ilalagay po natin sa matrix that from vertex 0 to vertex 3, yung weight ng edge ay 7. So, dito naman po, from vertex 0 to vertex 4, yung weight ng edge ay 8. So, ilalagay po natin sa matrix that from vertex 0 to vertex 4, yung weight ng edge ay 8. Okay. So, let us now go on to vertex 1. So, here sa graph, makikita po natin that from vertex 1 to vertex 2, yung weight po ng edge ay 1. So, ilalagay po natin sa matrix that from vertex 1 to vertex 2, yung weight ng edge ay 1. Dito naman po, from vertex 1 to vertex 3, yung weight ng edge ay 4. So, we're gonna put here in the matrix that from vertex 1 to vertex 3, the weight of the edge is 4. So, here, sa vertex 2, we would notice that all of the values are 0. Kasi nga po, makikita po natin dito sa graph that there's no edge coming from vertex 2. Wala pong edge na nagmumula sa kanya. Yung meron lang po ay yung edges na papunta sa kanya. At sabi nga po natin before, kapag directed graph, one way lang po yung relationship. So, let's now go on to vertex 3. So, dito sa graph, makikita natin that from vertex 3 to vertex 2, yung weight ng edge ay 2. So, ilalagay natin sa matrix that from vertex 3 to vertex 2, yung weight ng edge ay 2. So, that's it. And now, let's go on to the final vertex. So, vertex 4. So, dito sa graph, we can see that from vertex 4 to vertex 3, yung weight ng edge ay 3. So, from vertex 4 to vertex 3, the weight of the edge is 3. So, we have completed the adjacency matrix for this graph. Now, let us check kung tama po ba yung nagawa nating adjacency matrix. So, dito po sa graph, makikita po natin na merong 7 edges. So, 1, 2, 3, 4, 5, 6, and 7. So, dapat din po dito sa adjacency matrix, we can see 7 values that's greater than 0. Kasi nga po, sabi po natin kanina, kapag yung value po na nakalagay dito sa matrix ay greater than 0, it means meron pong edge between vertices. So, dapat 7 din po yung value that's greater than 0 na makikita po natin dito sa adjacency matrix. So, bilangin po natin 1, 2, 3, 4, 5, 6, and 7. So, makita po natin dito sa representation or sa adjacency matrix that there's 7 edges in the graph. So, tama po yung nagawa nating adjacency matrix to represent this graph here. So, yun lang po. Sana po na-gets po ninyo kung paano po gumawa ng adjacency matrix or gumawa ng representation ng isang weighted graph. So, we're done with the adjacency matrix. Now, let's discuss what is an adjacency list and how to make one. Adjacency lists for weighted and unweighted graphs are similar. The only difference is that we need to store an additional value in each node of a list corresponding to the weight of an edge. Sabi po rito, how we represent weighted and unweighted graphs using adjacency list is quite similar. Yung pinagkaiba lang po, if weighted graph yung gagawa natin ng adjacency list, ay kailangan nating maglagay ng karagdagang value o halaga na katumbas ng weight ng isang edge. Given here is the adjacency list for the previous graph na ginawan po natin ng adjacency matrix kanina. So since meron na po, tsaka madali lang naman yung concept ng adjacency list, ipapaliwanag ko na lang po kung paano ito nagawa o kung bakit ganito yung representation ng previous graph if we use an adjacency list. So, let's scrutinize it. Ito po yung graph na ginawa natin ng adjacency matrix kanina. Ito naman po yung adjacency list that represents this graph. The numbers in these boxes are the nodes or vertices na nandoon sa graph. We can see here that the graph has 5 nodes. That's why here we also have 5 values arranged vertically. Each node of the list contains 2 values. The first value is the label of a node of the graph. The second one is the weight of the corresponding edge. Bawat node or vertex daw po sa listahan ay mayroon ng dalawang values. Let's take for example, node 0. Makikita natin dito na sa kahilera ni node 0 ay may dalawang values na nakapaloob sa isang box. The first value is the label of a node of the graph. The second one is the weight of the corresponding edge. Yung unang value o number na makita po natin dito ay yung isa pang node or vertex sa graph kung saan konektado itong si node 0. Yung pangalawang value naman po ay yung katumbas na weight o bilang ng edge from node 0 to another node in the graph. So if we will read this representation, it goes like this. From node 0 to node 1, the weight of the edge is 3. And we can see here in the graph that indeed, the weight of the edge from node 0 to node 1 is 3. From node 0 to node 3 naman po ay 7 yung weight ng edge. And of course, ganoon rin po dito sa adjacency list. The weight of the edge from vertex 0 to vertex 3 is 7. And also, the edge 0 to 4 has the weight 8. Same lang din po yung process dito sa remaining vertices sa list. Kung mapapansin po natin, bakante po yung listahan ng neighbors ni vertex 2. Unlike in the rest of the vertices here in this representation, wala po tayong makikitang values sa tabi ni vertex 2. Kasi po, vertex 2 has no neighbors in the graph. For example, if an edge goes from vertex 1 to vertex 2, then 2 is said to be 1's neighbor. Pero si 1 po, hindi po siya neighbor ni 2 unless mayroon pong edge coming from vertex 2 to vertex 1. Sa ibang salita po, yung neighbors ng isang node or vertex sa graph ay yung vertices na pwedeng maabot mula sa node o vertex na iyon. So, dito naman po, from vertex 3, we can see here that from vertex 3 to vertex 2, the weight of the edge is 2. And lastly, here in vertex 4, from vertex 4 to vertex 3, the weight of an edge is 3. So that sums up the adjacency list for this graph. Let's move on to paths in weighted graphs. A path in a weighted graph is the same as in an unweighted one. The only difference is that in a weighted graph, a path has a weight that is equal to the sum of the edge weights in the path. Sabi po rito, magkapareho lang po yung path sa weighted and unweighted graph. But what exactly is a path? In graph theory, a path in a graph is a finite or infinite sequence of edges which joins a sequence of vertices. Sa ibang salita po, ito po ay ang pagkakasunod-sunod ng edges na dumurugtong o nagkakabit ng magkakasunod na mga punto o vertex sa isang graph. Ito ay maaaring may hangganan o wala. Ang path o ruta daw po sa weighted graph ay may weight na katumbas ng kabuuang bilang ng bawat edge na nakapaloob sa isang path. For example, consider a path 0 to 4 to 3 to 2 for a directed graph. Let's zoom in the graph po para mas makita natin yung path na tinutukoy dito. So here we can see edges along with the respective weights colored or shown in blue. This is actually a path which we can name or call as path 0 to 4 to 3 to 2 or the blue path. Mayroon pong 3 edges dito sa path which connect 4 vertices. Para mahanap po natin yung total weight ng path na ito, ay kailangan nating i-add yung weights ng bawat edges. From vertex 0 to 4, from vertex 4 to 3, from vertex 3 to 2, the edges weights are 8, 3, and 2 respectively. We just have to add those aforesaid values. So, 8 plus 3 plus 2 equals 13. So the weight of the path 0 to 4 to 3 to 2 or the weight of the blue path is 13. However, hindi lang po ito yung path from vertex 0 to vertex 2 na makikita natin dito sa graph. One may note that there is another path from the node 0 to the node 2, which is the path 0 to 1 to 2. Let's zoom in again the graph so we can see this another path. So here we can see another path with its edges and edges weights shown in red. Sa path na ito, mayroon pong dalawang edges na nagkakabit sa tatlong vertices. Para mahanap natin yung total weight ng path na to, same lang din po sa ginawa natin sa first path. We'll just add the weights of edges inclusive in this path. Mula po kay vertex 0 to vertex 1, yung weight ng edge ay 3. Mula naman kay vertex 1 to 2, the weight of the edge is 1. We just have to add those values. So, 3 plus 1 equals 4. So the width of the path 0 to 1 to 2, or the red path, is 4. Obviously, this is way less than the width of the first path, which means red path is shorter than the blue path. Let's assume that the weight of the edges sa bawat path represents the amount of time you need to pass through an edge. Ibig sabihin, kung pupunta po tayo from vertex 0 to vertex 2 at yung red path po yung gagamitin natin, mas mabilis po tayong makakarating sa ating destination point dahil mas mababa yung total weight ng path dito kumpara dito sa blue path. The problem of finding the shortest path, a path with a minimum weight between two nodes in a graph, often arises in programming practice. There are several algorithms solving the shortest path problem. Sabi po rito sa closing thought, yung suliranin sa paghahanap ng pinakamaikling path o ruta ay kadalasang lumilitaw sa programming. Pero gaya po kanina, finding the shortest path in a graph from one point to another is actually helpful in real-life scenarios. And that's where our report ends. We hope you have learned a substantial understanding on the mathematics of graphs. Thank you.